It's a great honor to introduce to you the speaker of today, Peter Strickx. Peter Strickx is the Chief Technology Officer of the Federal Government ICT Division, e-Government and ICT Service. And previous to that function, he held a number of management positions at Sun Microsystems in the Benelux. So Peter, with that, I'll leave the floor to you. You're going to present for 30 minutes, and then we'll answer questions afterwards. Peter, the floor is yours.
Thank you very much, Frederick. So basically, this is the bedtime stories of a storm chaser. Everybody's talking about cloud, so I wanted to stay in that analogy and talking about storms also, because not every cloud venture is a very happy trip, as you will see. And so the whole presentation, first of all, I will sketch somehow what was the context, what was the goal, what were the objectives of the cloud project. Then I'll explain a little bit of what we did and how we came to the call for tender that we issued in 2013. But I'll also explain the external elements that basically played an enormous role in the failure of this cloud trip. And so I hope that you will learn from this experience that I'm happy to share with you. Basically, I was more happy to share a success, but I think that you can learn as much, if not more, from the failure and preferably of others than yourself. So I'll do my best to be as open as possible and share with you the good things we did, and we did a lot of good things, but apparently they were not enough. And I will also explain some of the oversights that we had, and of course hindsight, looking back, is always perfect vision, is always 20/20, and so I hope that you will learn from that experience. This is basically the architecture of the federal infrastructure. FEDICT is responsible for building e-government building blocks, and so other agencies and federal public services can create applications using our building blocks. The building blocks are the network, of course, the FedMan. It's a high bandwidth network that connects all the federal services with each other and has a single gate to the internet. It's a 1 to 10 gigabit gate to the internet. In the midst, you'll see a federal service bus that is responsible for exchanging a lot of information between different federal public services and using the concept of authoritative sources, so that we should ask information only once from citizens and enterprises. And on top of that, you have the federal portal, where we host a lot of portal sites from the federal government. And to top it all off, you have the identity and access management layer using the EID token and even other means of authentication and authorization. So this is basically what we are running in our data center, are the different building blocks you see on that slide. So it's the network and responsible for the security of the network, the service bus to exchange information, the portal, and also the identity and access management layer. All of these elements are hosted in our data center. So if you see, this is what we had to run all these elements. They run in a fully virtualized dual site data center, meaning that the data center is basically an active data center over two physically different sites. The distance between them is approximately 10 miles. We have, for each and every application, we have a different virtual application silo. And so we have application silos for identity and access management, for example, for the whole application integration middleware, so the connection tier. And these silos we have in 3 different environments. So we have the test and acceptance environment, we have the integration environment, and we have the production environment. What is the difference between the integration environment and the production environment? The integration environment is basically an environment where our customers can test their application. So if they want to share some of the information with other federal public services, they can test their application on that environment that is basically a reduced copy of the production environment. But we use the test and acceptance environment for upgrading our own environment, and so we don't guarantee any stability with that environment. And so if you are a customer, or if you want to share more information with your peers, with other federal public services, the integration environment is the way to go. And so we have three different environments: test and acceptance, integration, and production. So we have also a very clear separation between infrastructure. These are different teams. We outsource all application development, so we have a lot of external people working on the environment too, and so they cannot access virtual application silos where they're not authorized. Okay, so this is basically the setup of the whole data center infrastructure environment in 2008. You will see the web tier that consists of 8 physical machines, and on these 8 physical machines we run approximately 70 virtual machines. Only the web tier, that's basically Apache. On the app tier we have 34 physical machines separated over the 2 sides, so that's 17, where we had 127 virtual machines, growing from 20 to 127. The database tier, which is an Oracle database, is not virtualized, and so we have there 6 machines basically shared over the 2 data centers. This is the picture in 2013, where you see an enormous growth in the number of virtual machines. We now go to 100 virtual machines in the web tier, but almost 350 virtual machines in the application tier. We reduced also the number of physical machines, as you will see, from 37 in the app tier to 8. That's by upgrading to the latest processor technology. We were able to do it a lot more with a lot less physical machines. So in the next slide you will see a high-level picture of what it all means. And so you have the internet access through the FedMan. We have also proxies, and several federal public services can access through the proxies. We have load balancing, we have intrusion prevention system in there, and then you will see all the different application silos and proxies and load balancing in there. So this is a very high level view. I will show you now a slide that also shows you a more accurate technical view. I have left out the IP addresses, of course, for security reasons, but there you will see the dual data center setup. So this is North Galaxy, and this is basically the Smalls data center. We don't own our own data centers, so we use the data centers from other federal public services, and these are the physical machines and the whole network layer and so forth that you can see in there. So we have a pretty advanced infrastructure setup. It was a call for tender in 2006, 2007. It was awarded in 2007, and it basically went into production in May 2008. And so we were up to replace that environment. The end of the contract was 2012 normally, and so we said that it would take at least probably 9 to 12 months to migrate to a different environment. And so we had no basically no idea of where we wanted to go in the next generation. We needed more flexibility, of course. We also wanted to capitalize on the virtual environments that already existed, and so I think it was a natural move to look into things like the cloud. And so for us, cloud computing is utility computing. And utilities are gas, water, and electricity, as you see on that slide. It basically means that you get compute and storage capacity as you need. You don't have to buy a lot of capacity, probably excess capacity up front, but also you have a pay-per-use model. If for the Texon web period you need to double your virtual machines, then you pay for those 6 weeks probably a lot more, yeah? But you should be able also to sign off and to decommit a lot of the virtual machines after the tax on web period, and you should pay a lot less than and not have to make an upfront investment to use the excess capacity or the needed capacity in that very busy period. And so also another form of looking into cloud computing is, of course, on the one hand, you have the service models that probably everybody is aware of, with software as a service, platform as a service, and also infrastructure as a service, but also different deployment models, whether you work in a private cloud, that I basically consider an oxymoron. It's like having a private nuclear plant, but of course sometimes that can make on the business side, and probably also to protect for security reasons, you have no other choice than set something up that looks like a private cloud. You have a community cloud, public cloud, of course, and hybrid cloud. We first looked very heavily into public cloud deployment models, but you will see what the advantages, but also the disadvantages were of that model. And on the essential characteristics side, you see all the good things that I noticed about utility computing, like on-demand self-service, rapid elasticity, measured service, resource pooling, and all that, and a pay per use model. Now, these are some of the examples that you see on the software as a service, platform as a service, infrastructure as a service. Basically, this presentation is about infrastructure as a service. So we don't envision platform as a service or software as a service from the start. It's clear that you can evolve into that model later on, but we wanted basically to keep things simple, infrastructure as a service to do that. And so here you see on that slide what is meant by infrastructure as a service. So we went either to the hypervisor model, so you get virtual machines, and some of the virtual machines were even installed with a pre-installed or delivered with a pre-installed operating system. But of course, our customers had the choice between different operating systems. So we basically were looking at delivering virtual machines where customers could put their own operating system, whether it be Windows, whether it be Linux, whether it be some other form of operating system that could be virtualized on there. It was their responsibility. And so this is basically the silo, the infrastructure as a service that we are talking about in this presentation. People underestimate the facilities. They think what we do ourselves, we can do better. That's not always the case. And as you can see, a lot of these everybody has a very good idea of how a data center and the facility should look like, but there's a difference between reality and your dreams. This is a picture taken in one of the federal public services, a smaller one, be it, but you could see there. But that basically was not the main focus point. We stated that the real danger is in the application layer, and the application layer is something that at first, if you want to do that in the cloud, there's a lot of problems associated with that. So that was one of the reasons why we deliberately did not want to cater for the application layer in our cloud model, and so we focused ourselves onto the infrastructure as a service model. Now, on the deployment side, some things, of course, you are very familiar with the private cloud and also with the public cloud. The Amazon and the Google clouds are of course nice examples of the public. It's not clear to me of the buy the material they need, or you have to guarantee a minimum pickup or take up of certain hardware, and your integrator is willing to pay for the extra risk and so install some extra capacity so that when you need to increase your capacity, it's there, and you can basically provision or onboard the whole virtual machines in less than 15 minutes or an hour. You don't have to go through a lot of paper tape to get the machines in your environment. The private cloud also typically means in your own data center. Yeah. And then you have the hybrid clouds, which is basically a mix of private cloud functionality, but also public cloud functionality. We looked seriously, of course. Amazon is the poster child of public cloud services, and so we looked at what are the advantages of going for a public cloud model. And of course, the one that stands out is economies of scale. You have a very low price in the big public cloud companies for virtual machines. But another important and often overlooked advantage of commercial cloud services is the lower project risk, since you don't use or you don't have to build it yourself. The project estimate on how long a project will take and the cost associated with that, you could have a pretty good estimate on that, because it's all proven technology and proven existing services. And of course, some of the providers, not all of them, but offer solutions with very high availability, and that was crucial to us from the federal government. Now, one of the cons and the disadvantages of commercial cloud services is, of course, that it's a take it or leave it service. You don't have any means of customization, which is normal. If you look into gas and water and electricity as utility computing, you're not able to customize that service yourself too. So that was one of the, and we wanted some of the cloud services to be adapted to our needs, and that was not possible. Of course, there was the question of, can we afford to have our data outside of Europe? We had in our call for tender a technical clause that basically prohibited cloud vendors to have data outside of Europe. We asked for a latency back and forth of less than 30 milliseconds, I think it was, and so that basically prohibited data coming out, data centers out of Europe that were outside of Europe. Another problem with commercial cloud services is that there's no standardization yet. A lot of people are talking about OpenStack, but you definitely risk to have a vendor lock-in situation where an exit at the end of the contract is not easy, and it could cost you a lot of money. And so that is definitely something we wanted to avoid. Then, of course, the opposite of the whole public cloud is a private cloud. It's definitely more tuned to our needs, but it's also a big project risk and extra costs because, of course, we needed to define a lot of those things, build it ourselves, and that was not easy. So looking into those environments, of course, what you do is mixing the advantages of the different models, and you look into the advantages of a commercial cloud service and also the advantages of a private cloud service, and hope to eliminate a lot of the disadvantages. And so you look into the hybrid model, where we basically wanted a custom web graphical user interface so that we could hide the complexity of the cloud vendors. And so we would say for some of the applications you could attack the private cloud infrastructure, but some of them you could also use the public cloud. But to our customers, it was a single self-service model, as you can see in the next slide. In this one, this was our vision in 2012 to have. So you see a central cloud services portal that we had to build, yeah, and that portal would communicate through standardized APIs with both our own infrastructure, so you could call that a private cloud, but also cloud environments from other cloud providers. And so you would have a single interface to all that. So that was our vision. But also that vision basically required a lot more development time, because we had to develop the cloud services portal ourselves, integrate the different cloud vendors, set up your own private cloud, but also negotiate SLAs with the public commercial cloud services. So that basically was a project of at least 18 and probably 24 months, and we did not have the time to do that. So we had to improve quality, improve speed, and of course improve efficiency and reduce cost by a serious factor. And so we said, how can we do that? How can we look and use the best basically of commercial cloud services, but still guarantee a sort of a private cloud? And so at that time, something came up called the virtual private cloud. The virtual private cloud is something that is very similar to a virtual private network, where in a virtual private network you build separate tunnels, encrypted communications on a public network. And so what we wanted to do is build encrypted environments, encrypted virtual machines in a public or in a commercial cloud provider environment. And so we could have basically the best of both worlds, and ensure the privacy, and of course also have the data and reduce the project risk. An important element in this setup was that from the start we envisioned owning the hardware modules that responsible for the encryption keys. So they would be put in our own data centers, and we would manage ourselves the keys that you need to encrypt all the information going out of your environment and basically decrypt coming in. So that was the setup, and so that was the idea of okay, this is what we want our cloud environment to look like. And now these are the components that we envisioned in our call for tender. You could see the client network over the internet, an interconnectivity service, of course the proxies to ensure and to have a certain form of security in there, a managed server set. A managed server set is basically an environment with a limited number of databases, but also operating systems that we would support. We would support Red Hat Linux, we would support Oracle Linux, and we would support Windows in there. And those were the managed server set, but an unmanaged server set is basically only the virtual machine. On the database side, we would support the Oracle, Microsoft SQL Service, also the Postgres SQL database we were looking into, and a DB2 database. So these were all into there. But of course, data privacy is certainly for government a very important topic. And so if you want to secure your infrastructure cloud, you have to look at different elements, contractual terms, audits, and you have to take control yourself of the availability and security. Trusting your cloud provider to do all that is not a good idea. But very important, trust must be earned, effort on both provider and customer side. But this is not only something you need to do in a cloud environment. I'm convinced that this is also something you need to do if you manage your own environment or work with outsourced or external companies that do some of the infrastructure management for you. So you should take these measures in a non-cloud environment too. If you look now at data versus privacy protection, of course, we were very, very concerned about personal data. We have some medical records on there. We have criminal records of people on there, and we don't want them to be published on the internet. So that was very, very important. Also, we wanted to secure access to our data centers only from our own services and not from an external service. So these were topics that were right in there from the beginning. And these are now the different parts in the request for proposal that we issued and we launched early 2013. So you had the basic cloud services that you could compare to commercial cloud services. We also had a standby cloud provider that was different and had to be different from the basic cloud service provider, and that was to avoid a vendor lock-in. And so we had from the start a vision of a standby cloud provider, also managed database services building on top of those two, 1 and 2, the basic cloud services and the standby cloud provider. Then 4, 5, and 6 are basically some management reporting functionalities and features that we asked for, and 7, 8, and 9 had to do with security, network, and also encryption. And so these are the 9 parts and that we were looking at, and we could have different providers for all of these 9 parts in the request for proposal. And so this is the timeline. Basically, we had a renewal coming up in 2012. But of course, we had elections in 2010, and we only had a government in December 2011. So the budget was not in time ready to discuss that. So we basically extended the original contract from 2012 to 2013. Then in November 2012, we got an okay on the budget, and in 2013 basically was the whole cloud journey that you will see that we started. We got a request for candidates in mid of March, and an okay from the Council of Ministers just before that, and the whole request for proposal was sent early July, or I think it was the 3rd week of July, not early July, but the 3rd week of July it was sent, and we had to have a decision in 2013, preferably before December 2013, or we would lose the budget that was allocated to the whole cloud venture. Now, the storm in there, everybody's talking about a cloud, and sometimes you have a lot of clouds or you have blue sky, but then this guy came in. Remember, it's 2013. We're still in May, June 2013. People who don't know this person, it's Edward Snowden that came out with the whole NSA debate and what the NSA did. And so suddenly you got a lot of politicians interested in data and IT not being housed in your own data center, but using infrastructure from American companies. But also we had a big issue in Belgium with Belgacom. Belgacom, I think it was in June, July 2013, they admitted they had some serious problems with hackers, and so they discovered a major breach of their infrastructure security, and it took a long time before that was cleared. So again, until now, we're not certain who was responsible and who was behind all that, but you can imagine that on the political atmosphere, the whole cloud basically turned into a tornado. And so things became a lot harder. We got a lot of questions from Parliament and so forth on the setup of our cloud services. And also the Privacy Commission came in first with a very negative advice. Later on, they basically turned 180 degrees with a positive advice, but then basically it was already too late to be in time to award the contract in 2013. So these are a list, or this is a list of a lot of the legal and other obstacles you have in setting up a cloud provider in the public sector, using a lot of privacy-sensitive data. Some of these things are all data seized in a criminal or social investigation should be stored on a carrier of the government, whatever that may mean, but also certain documents cannot be digitalized yet, and certain documents in the financial and banking area should be stored within Europe. Again, also criminal records, criminal files are in there. So very, very certainly we were looking at all these issues and things that we looked at were now looked by a lot of other people, and I had the impression that they were not looking through a magnifying glass, but through an electron microscope. And so there were suddenly new security requirements came up security levels that we don't have yet in government. So you have a level 0, which is public information, level 1, which is not public information, but not very confidential either. Level 2, it's already very confidential information, and level 3 would be very almost secret level of information. So they suddenly, the Privacy Commission required all the cloud applications to be in a certain category, and we had to do that. We did the risk analysis from ENISA, which is the European security agency, and they had some very, very good guidelines, and so we used them to do our risk analysis. We also asked for security certifications of the different cloud providers. We stated that data should be in Belgium or at least in Europe, and not outside of Europe, and we also required all the participants in the request for proposal to subscribe to the stricter EU privacy regulation. Yeah? Of course, that also meant a lot of visibility for the participants in this request for proposal. And so, if you look at the 9 parcels we had that I showed you earlier, we had to evaluate them on quality and price. And so, where you see a green box, as here, that means that the quality is okay, that all the requirements were there and were fulfilled. Price in an orange box would mean we could negotiate a better price, probably. Yeah, red means no way. The difference between what was offered and what was required is so big that even in an additional negotiation round, we could not basically cross the chasm. And this meant a red box. And so you see the standby cloud provider. We had very little offers on that side, and the quality was not there because they did not subscribe to certain security regulations that we required. 4, 5, and 6 we considered less important. And that was something that we could basically start even when the service was running. But to us, 7, 8, and 9 were very important, and 2 out of 3 were basically in the red. 1 on the quality, the encryption, but also 1 on the price, the virtualized security infrastructure, where we were very surprised on the price of these virtual appliances. And so this is the end of the journey, basically. Yeah? We had overall poor quality for some of the major parcels in the request for proposal. Some of the vendors later on explained to us that since this request for proposal got so much publicity, the high visibility for them meant also very high risk associated with that, and so they had to calculate a high insurance fee, and so that explained the very high price. But also we saw the resistance to change internally. Internally, a lot of the bigger agencies suddenly came up with reasons not to go with the cloud, and so we could not promise a critical mass to basically start with this request for proposal or tender. And so we had a difference between industry and government. What we wanted to add an additional security layer, where the industry said, we don't understand why you want this. Too few offers and candidates for certain services. Example, the backup cloud provider. And that also meant there was no price competition, and also a lot of high prices in there. The software licensing is still not cloud friendly, and that was basically the main reason why the virtualized security infrastructure was so expensive. The virtualized firewalls were almost as expensive as real physical firewalls, and so we in our setup and in our architecture, we said we will now have a different, because it's virtualized, different firewall for each and every application silo. But of course, if you multiply that with all the different application silos, we have now centralized physical firewalls, and we said this is too difficult to manage, so we will go to different virtualized firewalls for each application silo, but of course meant multiplying the number of firewalls by a factor of at least 10. Yeah? but we did not take the high prices of these virtualized firewalls into account, and that meant that the price for virtualized security infrastructure skyrocketed and was not within the foreseen budget. Also, what are the lessons learned today? And that was in 2013, the cloud offering was more expensive than on-premise. For the time being, I'm convinced, and I just saw an announcement yesterday or the day before yesterday from Amazon that they would dramatically drop the prices for their cloud services again, and they were at that time in 2013 by far the cheapest cloud service provider. They did not participate, however, in the call for tender. Also, the evaluation of cloud services, it was not easy. I think it would be a very good idea to do something like a proof of concept or a pilot first, and to see whether they everything they promise they can deliver, which is not always easy. But of course, if you have awarded that in a public call for tender, it's not easy to go back. And also, I think a thing we should have done differently is different subparts. I think we could have separated the cloud services from the additional security services in different requests for proposals, and so have a different request for proposal basically for the cloud and have a separate one for the local security infrastructure, and then we would probably have more participants in there, and since FEDICT was doing the integration, I think they would have accepted the risk and not built in a very high insurance fee into the whole pricing that they did. And so what are we looking at right now? We are building with the other federal public agencies, we are building a government cloud. It takes time because we have to have everybody on board, and we learned a lot from 2013. So we will build for certain services a proof of concept first, and then check with the participants whether that conforms to their needs, yes or no, and then we will build upon that experience and grow the cloud. But it takes time, and definitely 12 months. Again, looking back, 12 months is too short a time frame to do from defining the whole architecture into getting the approval of the Council of Ministers, publishing the request for proposal, negotiating with the different vendors and all that, have 2 or 3 negotiating rounds to check whether you can modify certain aspects of their replies, but the 12 months is definitely too short, and that's definitely a lesson that we have learned. Many of the principles will be maintained. One of them is the segregation of duties, which is very important from the security side. Also, the portability to another cloud provider, so we don't want any vendor lock-in. So all these elements come back in our private cloud approach, but it gives us more time, definitely, than having to push to a virtual private cloud. So everything is layered, and that was very important from the security side. We would focus on the infrastructure as a service and cloud model, because that at the time was the easiest one, and certainly from the security side, something that we control best. Be prepared for a lot of resistance, both internal and external. We even had some external companies explaining to us why they were not a big fan of cloud computing. One of the reasons apparently was that for some computer companies, when you deploy a cloud infrastructure in another European country, then the local country does not get any credits or bonus or whatever for that sale. And so they were pushing much harder for the on-premise and local or private cloud approach than for a virtual public cloud approach that we were looking into. But also a lot of internal resistance there from on the one hand, agencies that you would expect, but also from some agencies that you did not expect, a lot of resistance. Today, it's still not clear why the resistance was there. I think, and the mentality has changed a lot since 2013, and the people are willing even more to be on board now, and with a lot of the budget cuts, they don't have any alternative, and then to have more synergies together with other and working together with other federal public agencies. But it's also important to start small with a proof of concept and take your time to do all that. I think that was the last slide, Frederick, and that it's all open now for Q&A.
Okay, thank you, Peter, for this fascinating presentation. There were, as a matter of fact, 2 questions on the chat box. The first of them came from Richard, and he asked what made the Privacy Commission change their mind from negative to positive with their advice on that cloud project.
Well, it was. It's still something I did not understand. Initially, when we presented the case to the Council of Ministers, there was no question about involvement of the Privacy Commission. It was later on, when the whole Snowden and Belgacom thing came up, then suddenly the Privacy Commission was involved. And they said, okay, we would explain, these are all legal people, not IT specialists. And so when they asked us to explain at first our approach to cloud computing, and we did that, and they said, okay, we will look into that, we will look into your request for candidates and your request for proposal, and we will draft our advice, and then you could have, and if some things are not clear, you can come back for an additional explanation and this additional presentation and so forth, but we will definitely not issue a final advice before hearing you again. Yeah? And then I received, I think it was end of August, a very negative advice also sent through a lot of to a lot of the cabinets of the vice prime ministers, and so it got a lot of attention, a very negative advice. But basically, it was their negative advice was based on a lot of assumptions on the privacy and the fact that some things were not protected. Yeah? And then we explained to them. It took us because we did all the work before writing the request for proposal, and so we gave them 24 hours later the whole risk analysis we did with ENISA, yeah? Why we did things the way we did, and so we did a lot of explanation and calling to those legal people, and suddenly I had the impression that they were convinced that we were acting as a good how do you call it? In Dutch, it's called a huisvader. So we were taking the necessary precautionary measures to protect privacy, to avoid vendor lock-in and so forth. And all these things were in the request for proposal. And so we also explicitly asked for the candidates to sign a document that they would respect the EU privacy rules and so forth. And so when they saw all that, they really turned around. One thing that they kept in their advice was that applications that would be put on that cloud had to be categorized. And so whether it's a public or not privacy sensitive application or a privacy sensitive application and so forth. And so that was definitely also something that would set back the whole cloud adoption, because today there's no categorization whatsoever of any government application. So that was something that we would had to start from zero, and so that meant if an external federal public agency would have to put their application on the cloud, they would first have to go through sort of a screening whether it contained privacy sensitive information, yes or no, and in what category it was placed, and then depending on the category it was allowed to be on the cloud, yes or no. And so that was also something that could hinder the success. It was an impediment. It's definitely not a blocking factor, but it makes adopting the cloud a lot more difficult.
Mm-hmm.
I hope that was a good answer to your question.
I think so. There are two questions from Daniel as well. The last one was, given that your previous cloud journey was not implemented, can you tell us what sunk cost was related to the journey?
The sunk cost was basically the time that we spent with the team on it. We did not involve external companies in there. We had a team of approximately 6 to 7 people doing all the work on top of their other work and keeping the lights on in the existing data center. So that was the sunk cost. We did not make any investments that we had to throw away because we did not award the contract. But because later on we had to replace some of the older material, and we were counting on the cloud request for proposal to have all that updated. So we had to update in emergency mode some of the security infrastructure and some of the machines later on, and hope we can reuse them in our government cloud effort, but that's not sure. So if there would be sunk cost, it's definitely a sunk cost associated with having to upgrade some of the older material in early 2014 because the cloud was not ready then, and that we are not sure whether we can use that in our final infrastructure architecture, yes or no. But it's very limited. The sunk cost there, it's limited, not taking, of course, into account the whole cost of the team, 6 to 7 people working at that time more than 100%, because I think they had a lot of experience, and so keeping the lights on required probably 70 to 80% of their time, and we were doing another full time basically on top of that. But again, no external companies or consultants were involved, so the sunk costs basically are, I think, very, very limited. It's not, I'm convinced it's not 10K, not 10,000 euros. I'm convinced of that.
Okay, thank you for that. And then the second question of Daniel was more in the design of the cloud solution. What about the development environment? Where did that fit in?
There was no development environments because we don't do development ourselves. We outsource development completely, 100%. So there was no development environment in the cloud. And so we would basically issue the standards and the environment in our production environment, or the different platforms you have and applications you have to run on. But we've done that since 2007. That everybody that basically creates an application for FEDICT has to run on the test and acceptance environment, and so they can basically develop on a PlayStation or an Xbox for all that matters, but they have to deliver an application that is installable into our environment, in our test and acceptance environment. And so they know upfront what are the libraries we use, what are the platforms you run on. It's Java only. The databases will also have a dual vendor approach. So we have in the production environment an Oracle application server, but you also have to test on a JBoss open source application server to see that there are no vendor lock-ins into the application. These are things that we do on the acceptance mode, but we don't have a development silo in this environment.